Hey folks, so welcome back to some data science for paleontology and some R. So let's say you have some data and you want to search that data for some value. So this Neo world data frame, this is every test data amoeba surface sample data in the Neotoma database in one data frame. And I'd like to, in this case, I'm interested in subsetting it by position and then searching for the highest and lowest measured environmental variables in each of these positions, particularly pH and depth to the water table. You see, I was sort of graphed this in space. So the gray dots represent sampled space, and then you can see that there's sort of clustering around where there's lots and lots of sampling and some not so much here. So to do this, we're going to start with our libraries. We're going to need to read in our data. We're going to need to manipulate our data. And then we're going to need a way to get our data out of our data frame. And to do that, I'm increasingly fond of Clipper. Write Excel requires me to update my JavaScript, and I haven't gotten around to doing that yet. And then if you want a graph, you can optionally do your ggplots and cowplots to get this graph. So we'll start by importing data, which I've already done. Here, this is my big data frame, my Neo World data frame, and you can just change the directory to whatever you want. So what I've done, I have a list of coordinates that I want to search. What I've done is I've created this separate data frame in Excel, um, study coords, or yeah, I think that's what it's called. Anyway, so here I have a list of 13 coordinate pairs, and I'm going to try to write a loop to subset and search each one of these. So going back over here, I've just read this in using read Excel, changed the directory to your data. I was interested in subsampling the data just to make it a little more efficient. I mean, this is completely optional, but so we've got lat, long, pH, and water table depth here. Um, so the next thing you should do is find out the number of rows in your study coord. So how many, if you're going to do this in a loop, in a batch process, you need to do this. How many of these pairs, how many coordinates do you want me to search for? And in this case, we use the nrow command to get the number of rows of the data frame. Next, we're going to need a place to store the queried data from our subsetting. So for this task, I'm interested in the highest pH measured at a site, the lowest pH measured at a site, the highest water table depth, so the dryness measured at a site, and the lowest water table depth, which is the wetness measured at a site. Now, one major issue that you will have with this sort of thing is that if you search by lat long, which might be the most efficient way to do it if you don't know your site ID or site name, is that if the exact coordinate isn't in the data set, if it's not entered in exactly the same way as you've entered it into your search terms, you're going to show up with null even if the data's there. So, what I found a really good way to patch that is to just add a tolerance term. And so this is going to this is going to be the value plus or minus this value that we're going to set up like a bounding box around the coord, and we wanted to make it small so that we're not snagging adjacent sites, but big enough that if there's an error in either of the entries, that we will still be able to get it. um, so this is our central loop. So the first thing we're going to do for I in our 1 to the number of searches is we're going to, for each search, we're going to create a bounding box, lat high, lat low, long high, and long low. And all we're just going to do is take the latitude and longitude of interest from our study coords and add and subtract tolerances to them. Then I'm going to use this, I call it GODF. This is the dplyr filter command. And we are just going to um, set the conditions up so that any site in our bounding box gets added to the list. Now, for each one of our terms in the database, we're going to go, okay, find the max of the pH, the min of the pH, and make it the ith entry in this vector. Then, when that's all done, we're going to take all of them and we're just going to make ourselves a data frame in the order. So this is max TF. You can see max water table depth 44 centimeters, min 5 centimeters. The max pH was 5.5, the min was 3.79, and this is a bog site, obviously. If your search term doesn't show back, if it shows up as a null, you'll get this negative infinity, positive infinity as the answer to the min max. And this is because this is a data point in South America that is not in Neotoma yet, not at the time being. So that's why it returned that, but you can easily, just make sure that all the data you're searching for is in there, and you can, skip it if you have to. Now, for writing it out, I've been using the write clip function again from Clipper, and the reason I use this command is because, well, as I've said, I need to update my Java for the right Excel. But what you can do is copy and paste the clipboard. So you can copy and paste your data frame to your clipboard right into Excel. You can also do it into Google Sheets, but it will lose the formatting if you go right into Google Sheets. So what you got to do is into Excel first, and then copy and paste from that to Google Sheets. And that's the way to preserve the format. Okay. So then this is just some code that I've used to build this plot here. I just kind of wanted to visualize my data quickly. Some pretty advanced code just to get the grays and the dots. But I had this code because I'm using this for one of my dissertation chapter figures. So I just copied and pasted that. That's probably going to be a topic for a future video. Okay, so I hope this helps my budding digital paleontologists out there. Have a nice day, folks. Bye-bye.